Good morning, students. So in this session we'll discuss about the decimation in frequency radix to FFT algorithm for n is equal to 4 point and n is equal to 8 point structure. Okay. So decimation in frequency radix to decimation in frequency FFT algorithm. So how the structure will be? So first the basic 2-point computation for the basic 2-point butterfly computation. So for given two complex numbers a and b, so let's produce the two complex numbers a and b is equal to, so the lower wing should be -1. Okay, here the w factor w n k, so it is equal to now a, this is a plus, this is b, a plus b. In this computation this is a minus b, so b is equal to a minus b into w k. So in each computation the two complex numbers a and b are considered. So the sum of two complex numbers, the new complex number which gives the new complex number a, the subtract complex number b from a to get the term is a minus b, the difference term otherwise a minus b is multiplied with the total factor w and k to form the new complex number, that is b. So this is the basic signal flow graph. This is a signal flow graph or the basic 2-point computation. Since it looks like a butterfly, it's a butterfly structure, butterfly diagram, since it resembles like a butterfly. So in radix to FFT, we know that n by 2 butterflies per stage are required to compute to represent the computational process. In each stage let's say n by 2 butterfly required. Okay, now the 4-point first 4-point decimation in frequency FFT algorithm we'll see. So in decimation frequency, remember that the input should be natural order, the output is bit reversal order. So we'll take one example. For example, n is equal to 4, so it is equal to x of n is equal to 1 2 3 0 will take. Okay, so input should be in the natural order. So x of 0, x of 1, x of 2, x of 3. Okay, so we'll take another color for the butterfly structure. Okay, so decimation in frequency FFT, the structure will be, so this is the butterfly, first butterfly. And this is the first butterfly. The other one is we'll take blue color. This is the second butterfly. Okay, so the lower wing should have -1. This also should have -1. Okay, so the lower wing butterfly, so the structure will be this output. Our first butterfly, this is the total factor, no, basic computation, as per the basic computation. So this is W04 and this is W14, W14. Then the 2-point computation, we'll take this one. Another point, the 2-point computation. So the input should be the natural order, the output should be in the bit reversal order. X of 0, x of 2, this is x of 1, this is x of 3. The input is, this is input, these are the outputs sequence. Decimation in time FFT algorithm, that is a radix 2. So the arrow mark, so you see the arrow mark should be proper. Okay, so this output wing will be, so all the lower wings should be -1, lower wings should be -1. Okay, this is the arrow mark, for example. This is the arrow mark, this is the arrow mark, this computation is the computation. So the output, so as per the 2-point formula, W, okay, 0 4, this also W04. So what is W04 for this? N is equal to 4 means k is equal to 0 to n by 2 minus 1. So k equal to 0 to 1 to 4 minus 1. So this is 4 by 2, 2 minus 1, 1. So what is the total factor? E power minus j 2 pi by n into k. Okay, so already we derived, but anyway here k equal to 0, W0 n 4 is equal to 1. K is equal to 1 means W power 1 4, which is equal to n is equal to 4. So e power cos, so this is minus j. So this is minus j. Okay, this is minus j. W1 is minus j. So the basic computation now for the given data 1. So the input should be in the natural order. So you take the values 1, 2, 3, 0 as such. First stage, this is stage 1, this is stage 2, stage 2. So the first stage computation, 1 plus 3, this is 4, 1 minus 3, so this is minus 2 into this term, then 2 plus 0, 2, 2 minus 0, 2 plus 0, this is 2 minus 0, 2, 2 minus 0. So W0 in 1. So this is 4, this is 2, this is minus 2, minus j into 2, minus j into 2, a plus b, this is a minus b, a minus b. So W1 minus it minus 2j. So now 4 plus 2, this will be, okay, then I'll take this color. So this will be 4 plus 2, 6, 4 minus 2, 2, 4, this is W, this is 4 minus 2 into W01 is 1 also, no need to worry. 4 minus 2 is 2, minus 2, minus 2j, this term will be minus 2, okay, into 1, minus 2, this is minus 2, I'll let it here, minus 2, minus of minus plus 2j, okay. Now you can write the x of k is equal to, so x of 0 is 6, x of 1 is minus 2, minus 2j. While writing, this is bit reversal order. Output is, this is a natural order, this is a bit reversal order. Natural order. This is bit reversal order. Bit reversal order, okay. So 6 minus 2 minus 2j, and this is x of 0, x of 1, x of 2 is plus 2, and x of 3 is minus 2 plus 2j, okay. You can take another example. You can practice for the given sequence x of n is equal to 2, 0, 0, 1. Okay. So this also you can solve. Now we'll see the structure for this is decimation in frequency FFT algorithm. So we'll see the 8-point decimation in frequency algorithm. Okay. This is a decimation in frequency. Decimation in time algorithm. Decimation in time algorithm will take one more problem. Decimation in time, that is radix 2 only. Radix 2. Decimation in time, n is equal to 4 point. Decimation in time algorithm, FFT algorithm. Okay. So we'll take the values. X of n is equal to 2, 0, 0, 1. We'll take this value. We can take this value. 2, 0, 0, 1. So for a decimation in time algorithm, the input should be, this is bit reversal order. This is x of 0, this is x of 1, this is x of 2, this is x of 3, x of 3. Okay, so this is input should be in the bit reversal order. Input should be in the bit reversal order. Inputs are bit reversal order. For this basic computation is the two complex numbers a, b minus 1. So the two complex, it produces two complex numbers. A is equal to a plus, this is the total factor w and k. Okay, that is a w b in w n into b. Similarly, this b is equal to a minus wn into b. Okay, so the inputs should be bit reversal order. First x of 0, x of 2, x of 1, x of 3. Okay, the butterfly here each stage 2.5. First stage is a stage 1. Stage 1 minus 1, the lower wings are minus 1. Okay, so x of 0 value is 2, x of 2 value is 0, and x of 1 is 0, and this will be x of 3 value is 1. So the lower wings are w04 and w04. So in this case w04 is equal to 1, w14 is equal to minus j for 4-point DFT. So next one, the second stage computation will be, these are the two butterflies we have to consider. So otherwise we can consider another color. Okay, this one, this is this butterfly in the second stage computation, and one more butterfly this will take. Okay, so this is a second stage computation. So the first second stage computation, this lower wings minus 1. Similarly for this butterfly, lower wings minus 1. So the lower wings should have w04, this one will be w14. Okay, so the output should be, these are the outputs should be, this is decimal in time algorithm. Output should be in the natural order, x of 0, x of 1, x of 2, x of 3. Output should be in the natural, this is the natural order. Okay, 4-point decimal frequency FFT algorithm. So for the given the first stage computation, 2 plus 0, 2, 2 minus, this is 1 only, no, so 2 minus 0, Okay, 2, 0 plus 1, 1, 0 minus 1, 0 minus 1, 0 minus 1, okay, 2 0 0 1. Now 2 plus 2, second stage computation will be 2 plus 1 3, 2, this is 1, w0 is 1, so 2 plus 2 minus 1, this is 1, this is w minus j, minus into minus plus j, so this is this term will be plus j, because w14 is minus j, minus 1 plus j, so this term is plus j, so 2 plus j, this will be 2 minus j, 2 plus j, 2 minus, so now what is the x of k, which is equal to, this is natural only, 3 comma 2 plus j comma 1 comma 2 minus j. So the 4-point DFT, decimation in time and decimation in frequency algorithm we have seen. So similarly we will see the decimation in frequency for 8-point. So decimation in frequency radix 2 structure, decimation in frequency FFT, so algorithm. So here we'll see the structure, because the total factor is, we know, minus w per k is equal to e power minus j 2 pi by n into k, so n is equal to 8, so this is for n is equal to 8-point radix 2 decimation in frequency FFT algorithms, n is equal to 8, so in k is equal to 0 1 up to n by 2 minus 1, so k is equal to 0 comma 1, n by 2 8 by 2 4 minus 1 3, so 2 comma 3, so k equal to 0 and k equal to 0, w power k equal to e power minus, so k, so n is equal to 8, you will get e power minus j 2 pi by 8 to k, so it will be 4, e power minus j pi by 4, e power minus j pi by 4 into k, so k equal to 0, so w power 0 is equal to 1, w0 1, this is n, this is 8. So similarly we calculated w 1 8, which is equal to, so e power minus j pi by 4 into k, k equal to 1, so cos pi by 4 minus j sin pi by 4, so which is equal to 1 by root 2 minus j 1 by root 2, so this is w18. Okay, so w0 w1, this is w1, w2 k is equal to 2, so w 2 power 8 is equal to e power minus j pi by 4 into 2, so e power minus j pi by 2, so cos pi by 2 minus j sin pi by 2, so w2 8 equal to minus j. This also already we derived for decimation in time, also the same only, so w3 8 will be e power minus j pi by 4 into k is 3, so you will get e power minus j 3 pi by 4, so it is equal to cos 3 pi by 4 minus j sin 3 pi by 4, so you get minus 1 by root 2, j 1 by root 2 is W3 8. Okay, so this is 0.707 minus j 0.07 is minus 0.707 minus j. So you can write this also, minus 0.707 minus j 0.707. This will be 0.707 minus j 0.707. Okay. Now the structure will be, I'll draw the structure. So in decimation frequency, the input should be natural order, the outputs are bit reversal order. Okay, so the input should be, so n is equal to 8. Inputs are natural order. So the 2-point computations will write. So x of n is given. So 7 sequences. Okay, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. So the input should be in the natural order, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. So the first stage computation is a decimation in frequency algorithm. The first stage computation, the two complex numbers produce. So all lower, it should be all lower wings, butterfly lower wings should be minus 1, minus 1, minus 1. Sorry, this is a decimation in frequency, no? This is decimation in frequency. I draw a decimation in okay. Okay, I'll draw it. I'll redraw this one. No problem. Inputs are natural order. The outputs are bit reversal order. And how many stages for n equal to 8.3 stages. For each stage, how many butterflies are required? N by 2 butterflies are required. Okay, so the decimation frequency structure is the first stage has n by 2 butterflies, 4 butterflies. This first butterfly, then the second butterfly will be the second butterfly, then the third butterfly will be green color. Will take the third butterfly, the third butterfly, the third one, and the last butterfly will take another color, pink blue. This blue will take, this one will take. Okay, so all the lower butterfly wings should have -1. Butterfly have -1. All the butterfly lower wings should have the 12 factors. This is W08, this is W18, and this is W28, and this is W38. The 12 factors lower wing only should have. This is stage 1 computation. The stage 2 computation. So 4 butterflies, each stage 4 butterflies only. Okay, each stage it will be 4 butterflies only. So the second stage, the first butterfly. So this is the first butterfly. So this lower wing should have -1. Okay. Second butterfly. The second butterfly. The second butterfly. Similarly here. Sorry. I drawn wrong. Okay. These two only I have to connect. This is the first butterfly. So this is the first butterfly. The first butterfly. The second butterfly. This the second butterfly. This is the second butterfly. Second butterfly. So the lower wing should have -1. this one -1. Okay, so this arrow mark should have, you should put arrow mark also. Lower wings, similarly in the second stage, for each butterfly the computation for two complex numbers, properly we have to give the directions. Okay, so this output lower wing should be W08, okay, and this lower wing will be W28. Similar way, the butterfly for this one, okay, second one, each stage the number of butterflies should be n by 2, so 4 butterflies. This should be -1, this should be -1, this wing should be W08, and this should be W28. Okay, the third, this is stage 3. The stage 3, so the stage 3, the basic 2-point computation, or -1, -1, -1. So the total factor is W08. So the total factor is W08. W08. W08 is 1. So in some textbooks they won't write as W08 since it is a 1, but you should write -1, -1, -1. So now the outputs are, inputs are natural order, outputs are in bit reversal order. X of, so we can write green color, okay, X of 0, X of 4, X of 2, X of 6, X of 1, X of 5, X of 3, X of 7. Okay, so this is a structure for decimation in frequency. I written a radix 2. This is n is equal to 8 point. Okay, radix 2 decimation in frequency FFT algorithm. So you know how to calculate the total factors for the given sequence. You should be able to. So this, how the computation will be, a plus b, a minus b into W08. Okay, so the basic computation you should know. So what is the basic computation? Basic computation is a, this is b, okay, minus 1, this will be a is equal to a plus b. So here the another complex number b is equal to the difference a minus b into Wn per k. Okay, so Wn. Okay, so this is your basic 2-point computation for decimation in frequency 2-point butterfly. Decimation in frequency 2-point computation for the two complex numbers, so a and b. Okay, so a is equal to a plus b, and the other complex number b is equal to a minus b into W and k. So the same computation you have to do for the each butterfly. So the computation is same. Okay, only the structure, whether it is a decimation in frequency or decimation in time, the input should be in the the input are natural order for decimation frequency, the outputs are bit reversal order. Okay. So in the decimation in frequency algorithm, the input should be in the natural order, the output should be in the bit reversal order. Okay. So the 2-point computation you have to remember. So x of k you have to write, that is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, comma x of 7. So hope that you have understood the complete decimation in time and decimation in frequency structure for radix 2, n is equal to 4 point and n is equal to 8 point algorithm structure. For now, for any given sequence, input sequence, you can compute the output x of k, whether it is a, you can perform either by using decimation in time algorithm or you can perform using decimation in frequency algorithm. So you should remember the basic 2-point computation algorithm. So I can give some one of the problem for a decimation in frequency. So decimation frequency problem, you can take x of n, which is equal to decimation in frequency so 2 1, you take 2 1 2 1 1 2 1 2 2 1 2 1 1 2 1 2. So take this example, take this sequence x of n sequence. So you perform both decimation in time, radix 2 only. Okay, radix 2 decimation in time FFT algorithm and decimation in frequency FFT algorithm, and verify the output x of k. In both cases you have to determine the x of k only. Okay, x of n sequence is given, decimation in time and decimation in frequency FFT computation you have to do. Only thing is, the difference is the input should be bit reversal order and output will be in the natural order for decimation in time. For decimation in frequency, the input is in natural order, the output will be the bit reversal order. So while taking x of k, the sequence should be x of 0 to x of 7. Okay, so you can practice this problem for both decimation in time and decimation in frequency FFT. Thank you.